All right, I'm going to review some conditional probabilities. So, well, we have a deck of cards here. We're going to randomly select 3 cards from a standard deck of 52 playing cards. So we're going to select 3 cards from this deck. But we're going to have a few things going on. So we got to figure out what is the probability that all 3 cards are face cards when, part A, you replace each card before selecting the next card. So the best way to kind of tackle this is think about what are you doing. So we have a deck. We're selecting 3 cards. So I'm going to look at what's happening with the first card, the second card, and the third card. So what are we doing with all 3 cards? So we're going to take one, and we want all 3 of them to be face cards. Now, if you're not sure if what face cards are, is that's your Jack, Queen, and Kings. Those are all face cards. So what we need to know is what's the probability of getting 3 face cards when we replace each card before selecting the next card. We'll get to that in a second. So let's look at the first card. So first off, we got to think, we have our part over our whole, or the part we care about over the total amount available in our sample space. So our sample space has 52 cards available. So of the 52 cards available, how many of them are face cards? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them are face cards. So 12 out of 52. So I reached in the deck, I pulled out a card, hopefully it's a face card, 12 out of 52 chance of doing that. But here's the deal, I replace each card before selecting the next. So that card I pulled out, I'm going to put back in. So when I move to my second card, and I'm drawing again, I still have all 52 available because my first card was put back in. Well, how many of those 52 cards are face cards? Well, 12 of them are still face cards. But as I draw that second card, remember, we are replacing it, so we put it back in. So when I get to that third card, how many cards total are available? Still all 52 are available. So we have to count up, well, how many are face cards? Still 12. So since I'm trying to figure out the first and the second and the third are all face cards, we're going to multiply all these together. And when you do that in a calculator, you might want to put parentheses around that when you do that in a calculator to maybe organize yourself a little better. But when you do it, you should get 0.0123. Now, part B here, what we're going to do is we're going to change things up. What we're going to do is we are not going to replace each card before selecting the next one. So we're still looking at the first, second, and third card, and I am not replacing it. So let's start with, what's the probability that the first one's a face card? Well, there's 12 total face cards out of 52 total cards. But here's the deal. After I draw that first card, I am not going to replace it, meaning that's pulled out of the deck. It's now no longer available. So this first card was a face card that I pocketed. So when I move on to my second card, my entire sample space, well, I'm missing a card, so I'm now down to 51 cards. I have one less. But also remember, that card I pulled would have to be a face card. So I no longer have all 12 face cards available, I have 11. Notice how it decreased, because I pulled this first is a face card, now this second is a face card. Still not replacing, so when I get to that third card, I have now pulled out 2 cards, so I'm only left with 50 total. I've also pulled out 2 face cards, so I'm now left with 10 total face cards. So when you multiply those 3 together, you get 0.009 when we round that, I believe. So these are conditional probabilities. The condition up here is that you replaced it every single time. The condition down here is we did not replace the card every single time. Notice the difference there. When we replaced it, versus we did not replace the card. When you replace the card every single time, your probability is a little bit higher than what you would happen if you never replaced it. So you have a 0.009 is the probability that you pull 3 face cards without replacement. 0.0123 is the probability if we do replace it every single time. So let's look at another example here. So this is more in a table format. So the table shows the number of tropical cyclones that form during the hurricane seasons over a 12-year period. So we got to find the probability to predict whether the future tropical cyclone in northern hemisphere is a hurricane. So this is a little bit tough to kind of read. So on the previous problem, we knew we were dealing with our sample size. How many total are we dealing with? Well, we knew we were dealing with a deck. They gave us that, hey, you're dealing with a 52 card deck. Well, we have to figure out what do they give us this time. So it says find the probability to predict whether a future tropical cyclone in the northern hemisphere is a hurricane. So it's kind of hard to read, but they're telling us predict the probability that given it's in the northern hemisphere, what's the probability it is a hurricane? See that? So they're telling us, hey, we're looking at northern hemisphere hurricanes or northern hemisphere tropical cyclones. What's the probability that it is a hurricane? So the bottom piece, my whole, well, that's just how many total northern hemisphere cyclones do I deal with? Well, I have 100 northern hemisphere cyclones that are a tropical depression, 342 northern hemispheres that are a tropical storm, and 379 northern hemisphere hurricanes. If you add all of that up, that's 821, because I just added up this total, 821 types of tropical cyclones in the northern hemisphere. So I'm dealing with 821 on the bottom there. Well, of those 821 different cyclone events in the northern hemisphere, how many are a hurricane? Because it's the part over the whole. Well, the part is 379 are hurricanes. So 379 over 821. Well, if you divide those two, you get 0.462 is your probability. So looking at this second one here, it says find the probability, is what we're going to do, to predict whether a hurricane is in the southern hemisphere. So kind of the same deal. They tell us we're starting with a hurricane and give us the probability it is in the southern hemisphere. So I probably want to know, well, how many total hurricanes am I dealing with? And up top, I'm going to put my hurricanes that are in the southern hemisphere. Well, the amount of hurricanes I have is what? 379 in the northern hemisphere, 525 in the southern hemisphere. If you add those together, that is 904. 904. So kind of what's going on here is I'm doing the probability of A divided by the probability of A and B. And from what we talked about in class, that is your conditional probability there. So, well, how many total hurricanes do I have? That represents A, 904. So now I need to figure out how many total hurricanes and southern hemisphere do I have. Well, 904 total hurricanes. Well, how many were hurricanes in the southern hemisphere? Well, that was 525. So 525 divided by 904 becomes 0.581. 0.581 is the probability that you have a hurricane that is in the southern hemisphere, 0.581. One last problem to finish things out with conditional probability is we are at a gas station. 84% of customers buy gasoline. Only 5% of customers buy gasoline and a beverage. What is the probability that a customer who buys gasoline also buys a beverage? So I kind of hinted at it in the previous video. We're still dealing with conditional probability here because you need gasoline to get a beverage, or given that they bought gasoline, what is the chance that they got gasoline? So in this one, they looked at what's the probability that a customer who buys gasoline. So given they got gasoline, what's the probability that they also bought a beverage? So remember that probability is PA times PB given A. And this is the same as probability of A and B. They're asking us for what the conditional probability is. Given they're a customer who buys gasoline, what is the probability that they buy a beverage? So let's get this conditional piece alone. And I showed this in class too. So if I want to isolate this one, I'm going to divide by the probability of A, divide by the probability of A. So what you end up with is the probability of B given A is the probability of A and B happening divided by the probability of A. So the reason this works is they're asking us for this probability, so we need to do this piece here. So they're saying, given that they bought gasoline, that's the A part, what's the probability they also buy a beverage? That's B. So gasoline is A, beverage is B. So what's the probability that they bought gasoline? PA. Well, in the problem it says 84% chance customers buy gasoline, so we're going to divide by 0.84. But we need to put on top the probability that they got gasoline and a beverage. Well, that was only 5% of customers, which is 0.05. When you take 0.05 divided by 0.84, you end up with 0.0595 as that probability. And that was just a couple conditional probability problems.